All right, let's talk about something we use every single day. Opposite words. You know, good and bad, hot and cold, up and down. These seem so simple, so basic, right? But what if I told you there's a whole secret grammar hiding underneath them? A set of rules we all follow without even knowing it.
Just think about this for a second. Is the relationship between dead and alive really the same as the one between hot and cold? They're both opposites, for sure, but they just feel different, don't they? One seems so final, while the other feels more like a range. And that little gut feeling is actually the key to a really fascinating linguistic puzzle.
Now, there's a fancy word for all this. It's called antonymy. It's really just the official term for two words having different forms and opposite meanings. But here's the thing. That simple definition hides a ton of complexity, because believe it or not all opposites are created equal.
So, let's start solving this puzzle by getting one thing straight. Not all opposites work the same way. Let's start with the most straightforward kind. I want you to picture a simple light switch. It can only be in one of two states, right? It's either on or it's off. There is no in-between. And some word pairs work exactly like that.
These are called binary antonyms, and they follow some surprisingly strict rules. For one, they're totally mutually exclusive. If something is not dead, it has to be alive. Period. Another thing, you can't compare them. It sounds ridiculous to say someone is more dead or a little bit married. And finally, you can't really ask how. A question like, how dead is it? It doesn't work. Think about pairs like true-false or pass-fail. They fit this on-off model perfectly.
So that's the on-off switch. Pretty black and white. But what about all those opposites that have, well, shades of gray?
For this next category, let's ditch that on-off switch and think about a dimmer dial instead. You know, the kind you can turn. Suddenly, you don't just have two options, you have a whole range of possibilities. You can turn the light way up or just a little, making it brighter or dimmer along this continuous scale. Temperature is the perfect example here. Hot and cold aren't absolute states, are they? In between those two extremes, you've got this whole spectrum. Warm, tepid, cool. These are what we call gradable antonyms because they exist on a scale or a gradient.
So let's put them side by side. You've got the absolute on-off switch of binary words like dead and alive versus the super flexible dimmer dial of gradable ones like hot and cold. One is a clear choice. The other is a whole spectrum.
Okay, so we've got the switch and we've got the dial. But there's a third major type of opposite, and this one is all about relationships.
For this last category, I want you to picture a seesaw. For one side to be up, the other side absolutely must be down. They are totally dependent on each other. One side's very existence implies the other's. They're two halves of the same whole, locked in this perfect symmetrical relationship.
These are called relational antonyms, and you can spot them with a super simple if-then test. For example, if Mr. Brown is the employer, then it logically has to follow that Jack is the employee. You see, the existence of an employer requires the existence of an employee. One just can't exist without the other. And once you start looking for them, you see these pairs everywhere. If someone is buying something, someone else has to be selling it. If there's a parent, there has to be a child. Doctor and patient, give and receive, above and below. All of these pairs have that perfect seesaw symmetry.
Okay. So we've covered the three main types, but the most surprising rule of all is this kind of hidden default setting that's built right into our brains, one we use every single day. Get ready for this one.
When you ask about someone's height, what do you say? You ask, how tall are you, right?
And if you want to know the depth of a lake or a canal, you ask, how deep is it?
If you're curious about how much something costs, you'll ask, how expensive is this? You've seen the pattern, right? Well, now for the big question.
Why does it sound so fundamentally weird to ask, how short are you? Or how cheap is this? Or how shallow is the canal? We know what the words mean, but the questions just feel wrong, almost unnatural. And there's a reason for that, a really cool concept called unmarkedness. The idea is actually pretty simple. In a pair of these gradable opposites, one word is the neutral, default word. We call that the unmarked one. It's the one we use to ask a general question about that scale. The other word is marked, and we only use it when we're specifically talking about that end of the scale.
When you see them all laid out like this, the pattern becomes crystal clear. Tall is the default word for the entire scale of height. Deep is the default for depth, expensive for cost. We ask, how tall are you, even if we expect the person is short. We only bust out the question, how short are you, if we already know they're short and want to focus on that fact. It's such a subtle but really powerful rule.
So, from on-off switches to dimmer dials and all the way to these hidden default words, the main takeaway is this. The way we use opposites isn't just a random collection of habits. It is a highly structured system with this incredible, invisible logic running just beneath the surface of everything we say.
And this whole idea of a hidden default word is probably a lot more powerful than you think.
Which really brings us to a final pretty big thought. If our language has these built-in default settings for something as simple as opposites, what other hidden defaults are baked into our words? What other invisible rules are shaping how you ask questions, how you frame arguments, and ultimately how you actually see the world every single day? It's something to think about for sure.